This section sets the stage for the quiz. We're dealing with scikit-learn's train_test_split function, which is used to divide a dataset into training and testing parts. The key here is that we have a dataset with 1000 samples, and we want to make sure that we get the same split every time we run the code. This is where the _random_state parameter comes in. This further clarifies the problem. The dataset size, 1000 samples, isn't directly relevant to understanding _random_state, but it provides context. The focus is on the consistency of the split, getting the same training and testing data each time you run the code. This is the core question. We're asked to identify which statements accurately describe the behavior of the _random_state parameter in train_test_split . This is the actual multiple-choice quiz component. This statement presents an option to consider. It incorrectly suggests that a specific integer for _random_state results in different splits. This will be assessed as correct or incorrect against the functionality of _random_state . This statement is another option. It correctly asserts that _random_state manages how the data is shuffled before the split is made. This affects the reproducibility of the split. Here is another statement to evaluate. It suggests that omitting _random_state leads to different splits each time the code is executed because the data shuffling is not controlled. This will be tested against how _random_state is used. This is the last multiple choice option. This proposes that using none is akin to picking a random integer for each _random_state value. The correctness of this statement should be analyzed within the quiz framework. This refers to the portion of the dataset used to train a machine learning model. train_test_split divides the original dataset into two parts, a training set and a testing set. The training set is used to teach the model how to identify patterns and make predictions. This refers to the portion of the dataset used to train a machine learning model. train_test_split divides the original dataset into two parts, a training set and a testing set. The training set is used to teach the model how to identify patterns and make predictions. This refers to the portion of the dataset kept separate from the training set. It's used to evaluate how well the trained model generalizes to new, unseen data. The testing set is crucial to understand how effective the model is at making accurate predictions on data it hasn't been trained on. Think of it as a final exam for the model after its training. This refers to the portion of the dataset kept separate from the training set. It's used to evaluate how well the trained model generalizes to new, unseen data. The testing set is crucial to understand how effective the model is at making accurate predictions on data it hasn't been trained on. Think of it as a final exam for the model after its training. Hey Vamsi, let's break down this crucial part of the train_test_split function in scikit-learn. It's all about how we split our data into training and testing sets. The train_test_split function is used to randomly split a dataset into training and testing sets, which is an important step in building machine learning models. It helps in evaluating the model's performance on unseen data and preventing overfitting. The _random_state parameter is what dictates how this random split happens. Think of it like setting a seed for a random number generator. The same seed always produces the same sequence of random numbers, ensuring a consistent split each time you run your code. This simply tells us the size of the dataset we're working with, 1000 samples. Knowing the size of the dataset helps us understand the scale of the problem and the computational resources required. It doesn't directly affect the _random_state parameter's behavior, but it provides context for the problem. The core question asks us to consider different scenarios related to the use of _random_state in the train_test_split function. We need to identify which statements accurately reflect the behavior of _random_state concerning the splitting of the data. This is the prompt for the quiz, setting the stage for evaluating our understanding of the role of the _random_state parameter in the function. which is a fundamental aspect of reproducible machine learning experiments. This sets up the core focus of the quiz questions which follow. This option explores the effect of assigning a specific integer value to _random_state . The key point is understanding whether this leads to a different split each time, or the same one. This statement directly addresses the role of _random_state in the data shuffling process before the dataset is split into training and testing sets. It probes our understanding of how _random_state affects this shuffling stage. This option is crucial because it explores the case where _random_state isn't specified. It tests if we know what happens when no seed is set. Will the split be consistent across multiple runs, or will it change? This option tests our understanding of the "none" value for "random_state". Does "none" act like a different random seed each time, or is there a different outcome? Okay, let's dive into the scikit-learn's "train_test_split" function. It's a crucial tool for splitting your data into training and testing sets. A key part of this function is the "random_state" parameter. We'll explore its role in controlling how the data is split. The core question here is about understanding how "random_state" affects the "train_test_split" function. This parameter plays a vital role in ensuring reproducible results when splitting your data. Let's examine statement A. It claims that setting "random_state" to a fixed integer, such as 42, will result in different splits each time the code runs. This is incorrect. A fixed "random_state" ensures the same split every time. The randomness is controlled and reproducible. Now, statement B. It suggests that "random_state" is used to control the order of data before splitting occurs. This statement is correct. The "random_state" parameter acts as a seed for the random number generator. Using the same seed will always result in the same shuffling and subsequent split. Statement C says that if you leave out the "random_state" parameter, you'll get a different split each time you run the code. This is correct. Without "random_state", the splitting process relies on the system's default random number generator, which changes across runs, leading to variations in the splits. It's like shuffling a deck of cards without a specific method. You'll get a different shuffle each time. Let's look at statement D. It claims that setting "random_state" to "none" is the same as choosing a random integer each time. That's incorrect. "none" means that there's no seed, essentially the same behavior as omitting "random_state" entirely. Hey Vamsi. This line introduces the core concept. We're exploring how scikit-learn's "train_test_split" function works, specifically focusing on the "random_state" parameter. This parameter is crucial for controlling how the data is split into training and testing sets. It's all about ensuring we get consistent results. We're working with a dataset containing 1,000 samples. This is the total amount of data we are splitting. The main question is, how does the "random_state" parameter in "train_test_split" behave, particularly regarding the consistency of the data split across multiple runs of the code? This is a multiple-choice question. We need to identify which statements accurately describe the effect of "random_state" on "train_test_split". This helps ensure we're using the function correctly for reproducible results. This is about whether using a specific "random_state" value will change the way data is split every time. Let's analyze if that statement aligns with the function's behavior. This is checking whether the "random_state" directly affects how the data is shuffled before splitting it into training and testing sets. We need to verify its accuracy. This option explores the situation where "random_state" is left out. Does it lead to inconsistent splits every time? We'll confirm this statement's correctness. Here, We're seeing what happens when random underscore state is set to none . Does it mean a random integer is selected for each run, making the process inherently different each time? Hey Vamsi, this line introduces the core concept of the problem. Understanding how scikit-learn's train_test_split function works, specifically focusing on the random underscore state parameter. This parameter is crucial for ensuring that the way the data is split into training and testing sets remains consistent across different runs of the code. Think of it like a recipe. Using the same random underscore state ensures you always get the same batch of data for training and testing. Here's the core question, Vamsi. It asks you to identify which statements accurately describe the behavior of the random underscore state parameter when splitting data using train_test_split . We need to understand how it affects the randomness and reproducibility of the split. Let's analyze statement A, Vamsi. This claims that using a fixed random underscore state like 42, will result in a different split every time. This is actually incorrect. A fixed value for random underscore state ensures that the split is exactly the same each time. It's like setting the seed for a random number generator. The same seed gives the same numbers, and thus, the same split. Statement B says random underscore state controls how data is shuffled before the split. This is, before splitting, the data gets shuffled randomly. Random underscore state acts like a master key, determining the shuffling pattern. If you use the same random underscore state the shuffling will be identical each time. Statement C is about leaving out random underscore state This is also, without random underscore state the shuffling is based on the system's current random seed which changes across runs. Therefore, the split will vary each time you execute the code, similar to rolling dice. Let's think about statement D. It suggests that random underscore state equals none is the same as choosing a different random integer each run. That's, random underscore state equals none actually means no seed is set, leading to a non-deterministic split, similar to omitting random underscore state completely.